So we'll be looking at trigonometric ratios. Trigonometric ratios. So in this, we'll be looking at the sine and the cosine rule. And under sine and cosine rule, we'll be looking at our ability to apply the sine and cosine rule to find the unknown sides and angles of the triangle. Then, secondly, we'll be able to analyze geometrical figure using the sine and cosine rule to find the missing side and angles of a given triangle. And also, we can apply the sine and cosine rule to explore the concept of bearings in solving trigonometric ratios. So this is what our main focus will be on this topic of sine and cosine rule. So on this, I would like us to take a brief revision on trigonometric ratios. Looking back at the right angle triangle. The right angle triangle is the angle at 90 degrees. So we are taking a look at the right angle triangle. So if you look at the right angle triangle here, is the angle at 90 degrees. We look at the longest hand of a right angle triangle, which we call the hypotenuse. The hypotenuse is the longest side of your right angle triangle. So you should always watch out for the longest hand of your right angle triangle. Then we look at the marked angle given to us here. We look for the place opposite the marked angle, facing directly, we call it opposite. So that is why I'm marking this point as the opposite of my right angle triangle. Then the other side of it, adjacent to the angle, is the adjacent of our right angle triangle. So this is the basics we have learned on trigonometry. Then I'm giving another triangle in this. So for this second triangle, taking a look at this second triangle, we have our angle theta marked here. And where theta is marked, you look at the place facing your theta, that point. So that point is the opposite to your theta. Then, like I said earlier, the longest side of it is the hypotenuse. So this place still remains our hypotenuse because it still remains the longest side of your right angle triangle. And the other side is our adjacent. So having understood this, you should be able to locate where your opposite is and the adjacent to your right angle triangle. These are the points that you might have a little issue with where the hypotenuse. Always watch out for the longest hand of your triangle. This is the longest of this right angle triangle. So we are going to apply the basics of trigonometry in solving the right angle triangle. For example, if we have the Pythagoras theorem that gives us that h squared equals opposite square plus adjacent square. So the longest hand, which is our hypotenuse square, is our opposite square plus our adjacent square. So you should have this in mind. This is Pythagoras theorem when it comes to the application of trigonometry. And if you are looking for the opposite side, we have it as our h square minus our adjacent square. And when you're looking for the adjacent square of your right angle triangle is your hypotenuse square minus your opposite square. So how do we apply our trigonometry to finding the right angle of a triangle? So if you are given a right angle triangle with your opposite and your marked angle, without the hypotenuse. So given this right angle triangle, I am going to look for applying the trigonometry ratios in finding an angle or a side of the given triangle. For example, if I am looking for my angle theta, I'll be applying the SO theorem in finding this, where we have our SO. S in SO is sine theta, that's sine of angle. Our O, already established from this, is our opposite. And the H is the hypotenuse. So we have our sine theta. We have sine theta here as opposite divided by hypotenuse. So this is our sole principle, opposite and hypotenuse for sine of angles. Then for CAH, CAH, C is cos theta. Then our A is our adjacent of the angle. Then the H is the hypotenuse of your triangle. So that is cos theta. Then we have 12. Tan is our T. Then O is our opposite. Then A is the adjacent. So we can simply say tan theta is equals to opposite divided by your adjacent of angle.